Okay, this I'm just showing because I saw this a couple years ago. This is, so do it yourself. This is obtaining stem cells from the placenta. So I could just imagine, oh honey, it's great, I'm glad the baby's here, give me the placenta because I'm going to get the stem cells. You know, this is really a do-it-yourself. It's like this guy has this in his garage or something. So I won't go through everything, but we pretty much take, wherever we're getting it from, we have to just get those stem cells out and we spin them away from the other junk that's there, and then we freeze them. So it's the centrifuging, spinning them down, and then freezing that's important here. This was somewhere in England I got this particular thing from, so it was nice. So this just sort of shows the steps we take to isolate adult stem cells. So, you know, basically they take this item, they rinse it, they collect those cells, and they also spin them down so they've got two different, you know, they've got different collections of cells. Then they're going to freeze it, and that's essentially what you do. These guys look really big. This is our rebooting slide. So I want you to read the words that pop up with everything you can possibly give me. Say it. They're so cute. They really are. Although I didn't expect them to look like monstrous dogs. Because I wasn't expecting like they're coming down at me. Anyway, so that's just our 30-second break from science. So we're going to go on because we've looked at already some of the history. We've looked at the different types of stem cells, and we've looked at how we isolate adult stem cells, and that they come from all different sources. So now we're going to look at isolating embryonic stem cells. So you guys have probably seen pictures like this. So this top picture is this very first fusion of sperm and egg, and we have, you can just barely see two little nuclei in the middle there, just barely. Then this will just start dividing. And within about 18 hours, we'll have about 8 cells. And this abbreviation for PIGD stands for pre-implantation genetic diagnosis. So if you went for in vitro fertilization, you really wanted a baby, but were having trouble, so you could have the egg and the sperm put together in a dish, and then you could say, well, I want to make sure that this child does not have this disease that runs in our family. We want to make sure we're having a girl. What they do is at this stage, they take one of those cells out, and the embryo proceeds developing as normal, despite the fact that we've taken out one cell. And then we can analyze that cell and look, does it have any disease, genetic disease? Is it a boy or a girl? They can tell that. So what's useful about that is that, well, wouldn't that be nice if we just took one of those cells? It's not going to harm the embryo, right? Took one of those cells, allowed it to proliferate. That could be our source of embryonic stem cells. Of course, the proliferation of just one little cell takes a very long time, so this isn't as useful as we would think it would be. So, and then after about 5 days, we end up with this structure that's up there. Again, that hollow ball with that inner mass. So that's called a blastocyst. I won't ever probably see you again to ask you to tell me that word again. But anyway, that blastocyst is where we take our cells. And we take those cells out and we put them on a dish of those support cells like I showed you earlier, so like the adult holding the baby. And this allows the cells to grow very nicely, very comfortably. And then we take some of those cells and we freeze them, and then we can take the rest and we can start adding different chemicals to make it become a neuron, to make it become liver, to make it become bone. So that's what's happening there. These cells are pretty amenable. When we tell it to do something, it'll go, sure, why not? You know, I've got nothing better to do. I haven't had other instructions given to me before. So that's one of those wonderful things about embryonic stem cells is they're very plastic. That's the word we use when we say they can respond to any cue that we give them. The problem is we don't know all the cues. So sometimes we'll give something and just wait to see what happens. We don't always know what's going to happen. We just have to wait and see. So everything takes a very long time. Everything I'm presenting takes hours and hours and hours in the lab and lots of thinking and lots of frustration. So how about how about we make an embryonic stem cell that's just like you? Because we're all adults, right? So we can't have an embryonic stem cell just like us. But if we wanted to make a new heart that matched us, we would really want to use our cells, turn that into a heart so when it comes into us, we don't reject it. But we know that embryonic stem cells are better in the way that, they're going to last longer, they're going to be more amenable to us working with them. So let's make an embryonic stem cell just like us. So the way we do this, and the way we make Dolly the sheep, and the way we make that puppy Snuppy, is we take an egg cell from the mother. And so this is pretty much only going to work for women, pretty much at childbearing age even. So what you're going to do is take an egg from the mother. And then you're going to take a skin cell from that same mother. So this would work for me. So we'll take one of my eggs, and we're going to take one of my skin cells. And we're going to take this nucleus out of the egg. Remember, it's only half the number of chromosomes we need. It's only half the recipe book. We want to put the whole recipe book in this cell. So we're going to take the recipe book, the nucleus from my skin cell, and put it in the egg. And then what we do is we give that egg a little shock because that sort of wakes it up and it says, oh, I've been fertilized, essentially. And then it's going to start dividing and becoming an embryo. So what will end up is that embryo there, that blastocyst there, will be something very much like me. And that would then, we'd be able to take those inner cells out, grow them on a dish, and those cells are going to be just like me. My body wouldn't reject them. It would take a really long time to grow a heart, so I'm hoping I have a long time to wait. So we aren't able to grow a heart yet. So the thing about this, it's a low rate of success. This is essentially cloning. This is what we call therapeutic cloning. So cloning is very, very tricky. It's a very slippery technique. It's very difficult to do this. So in theory, we say this. We've made Dolly. We've made Snuppy. We've made a monkey. But we aren't able to really get this very successful. So the number of tries they had to do to make Dolly was tremendous. So it's not that easy. So I think the fears of us making, lots of people, lots of me's running around is pretty low.